All right. It looks like now they just go over the answers to this. So there's your longest chain. There's where you start numbering. All right. I don't know why they stopped at 6. See how they have the, oh, they're just showing you 2 and a 6. You have a methyl, you got an ethyl, you got a methyl. So the answer is 5-ethyl, 2,6-dimethyl-hectane. And what's interesting is they don't say anything about this di. That is very interesting. Well, like I said, that's why you got me. All right, so the E and the M. You do not use the di when you do alphabetizing, or the tri or tetra. Don't use that. Use the actual name. Okay, cyclical alkanes. All right, basically the same prefixes, but you put cyclo in front of it. Now, we don't have a cyclomethane and cycloethane because they only have 1 and 2 carbons. So the simplest cycloalkane we have is cyclopropane. And that is 3 carbons. And we got cyclopropane, cyclopentane, and cyclohexane. These are the most common cycloalkanes, most common in nature. Most common. All right, we'll learn it in a biochemistry chapter. The structure of cholesterol, all right, is a 6, 6, 6, 5 carbon chain system. If you see this kind of structure, it is some sort of cholesterol. It's a hormone. These are very common kind of structures, and you know, you've got OHs hanging off here, and other groups hanging off there, and things hanging off here. So all depending on the type of groups you have, you can change the type of compound from cholesterol to a hormone of some sort. All right, but these 5 and 6 member rings are the most common: cyclopentane and cyclohexane. Cycloheptane, cyclooctane, cyclononane, those are just really not that common. They obviously do exist, but they're not that common. So how do you name this? Exactly the same way, but you don't forget the cyclo. All right? So it's still an alkane, but you know, it's like methyl cyclohexane. What do you think? Here, I'm going to write this down. Methyl, and I think we go over this, but I think you guys can already do this. Cyclohexane. Why don't you draw what you think this looks like? I'll give you about 5 seconds. All right, so it's a cyclohexane, so it's 6 carbons, and I got a methyl group. Boom, that's it. It doesn't matter where you put the methyl. If you put the methyl down here, that is still methyl cyclohexane. You don't have to number it. Why do you think you don't have to number it? Because it doesn't matter where you put it, it's the same molecule. On a straight chain, it's important. All right, like if I have a straight chain, is our methyl on the second carbon? Is the methyl on the third carbon? Is the methyl on the fourth carbon? Okay, where is the methyl? But on a cyclical compound, it doesn't matter where you put it. So you don't have to number it if you have one group. Okay. So how to name cycloalkanes with the IUPAC system? It's very simple. The ring is always the parent. The ring is always the parent. All right, so this is a cyclohexane. All right, now just by looking at this, now in this case I have 2 substituents. I can't just say ethyl methyl cyclohexane. I got to tell the reader specifically how far apart these are from each other. Okay, so now I have to number it. Well, where do you think I start numbering? Do you think I just start at 12 o'clock just randomly? Or do you think I look at the groups and I determine which one alphabetically is first? Wouldn't that make sense? Ethyl is before methyl. So this is carbon 1, this is carbon 2, this is carbon 3. So it's 1-ethyl, 3-methyl cyclohexane. Now, I believe we do this, but, you know, why not just do it right now? You guys will be wondering anyways. Oh, cyclo. Now, I always forget the cyclo. A lot of people do that. Just be careful with that. So 1-ethyl, 3-methyl cyclohexane. Okay. Name and number the substituents. No number, here it is, no number is needed for a cycloalkane with 1 substituent. Just like I said, methyl cyclohexane. It doesn't matter where you put it, it's the same molecule. All right, look at this, butyl cyclopentane. It doesn't matter where the butyl group is, you don't have to number it. It's only when you get to 2 or more. Okay, when you get to 2, you begin numbering at 1 substituent. Okay, then proceed around the ring that gives the lowest numbering. Okay. The 2 different substituents number the ring to assign the lower number to the substituent alphabetically, just like we said. Now, in this case, these are the 2 same compounds, so it's 1,3-dimethyl cyclohexane, not 1,5. I don't go 1, 2, 3, 4, 5. go the direction that gives these in the lowest numbers. All right, here's ethyl, ethyl, methyl. Ethyl is alphabetically first, so that's why we use ethyl. Okay? Make sense? I hope it makes sense. That's actually the end of this part. I'm actually going to end it right here for cyclical alkanes. And then when we come back, we'll just talk about hydrocarbons and some properties.